without satellites, without GPS? How have we managed to map the Earth so precisely? Well, 2,000 years ago, a man named Eratosthenes did the impossible. He calculated the size of the Earth almost perfectly. So how did he do it? Well, you might have heard the saying, how do you eat an elephant? One bite at a time. And that's exactly what Eratosthenes did. He took small pieces of information and put them together to get the big picture. It all started when he was working in the Library of Alexandria, arguably the greatest library of the ancient world. It's said that one day he noticed something strange. The shadows cast by the sun at noon on 2 different days were different. In other words, the length of a shadow changed depending on the time of the year. And this gave him an idea. He traveled south about 5,000 miles to the city of Syene. According to legend, this is where he dropped his bread, looked up at the sky and said, "I have rounded the earth." But how could he possibly know that? Well, you see, realized that the difference in the angle of the sun between Alexandria and Cyrene at noon on the summer solstice provided enough information to calculate the Earth's circumference. Here's how. Let's take a look at this map. Here is Alexandria, and here is Cyrene. As we can see, they are almost exactly in the same longitude. So the difference in their latitude must be equal to the arc of a circle. But what does this mean? Well, imagine slicing this globe along its surface from pole to pole. If we then unfold the slice, it becomes a flat piece of paper, which we call a sector. Notice that the central angle of this sector is just 1 degree. And if we were to repeat this process for every degree around the entire circle, we would end up with a strip of paper that looks like this. And the length of this strip is just 1 degree of the Earth's circumference. So now let us return to our map and look at the angle of the sun in Alexandria and Cyrene. Because the sun is directly overhead in Syene, its angle is 90 degrees. But in Alexandria, it's only 71.5 degrees. So the difference is 18.5 degrees. And because we know that the length of 1 degree of the Earth's circumference is 60 miles, the total length of the arc is 18.625 times 60 miles, or 1,117.5 miles. But we know that this arc is just half of the entire Earth's circumference. Therefore, the Earth's circumference is 2,235 miles. And believe it or not, this is almost exactly right. The real circumference of the Earth is 24,860 miles, which means that Eratosthenes was off by less than 1%. But it gets even crazier. You see, Eratosthenes didn't actually set out to measure the Earth. He was only trying to figure out how tall a specific obelisk was in Alexandria. But thanks to some creative thinking, he ended up calculating the size of the entire planet. And this brings us to the moral of the story. If you want to accomplish something great, don't just take the information that you already have. Instead, look for new ways to use it and don't be afraid to think outside the box. Who knows? You might just end up measuring the Earth. Now, if you're enjoying these videos, but you want to take your learning to the next level, we've got the perfect solution for you. Just hit the thumbs up button and don't forget to subscribe.